Okay, I'm going to talk about groups acting on sets, or sometimes you say a group action on a set. Suppose we've got a group. Suppose we've got a group G dot. This is a group, and X is just a set. Then we define a group action. There's different ways of writing it, but really what I'm doing is mapping the order pair Gx, where G is a member of the set G and X is a member of my set X. It's mapped to, and you normally just write it Gx. And basically it's a mapping from G cross X to X. So Gx is a member of the ground set G. This is of course what's called a left action, because I'm writing the group element to the left of the X element. Well, if that was all we had, then we could just put any old rubbish here. But in the same way that when we talk about maps from one group to another, we needed the group homomorphism rule. We needed that phi of xy was equal to phi of x phi of y to define a homomorphism. And once we got that, then a whole bunch of things followed. We need two rules. Firstly, we need to know that Ex equals x for all x in X. This E, of course, is the identity of group identity element of G. And we need a second rule here, which is more for completeness. Or, well, you can make of it what you like. If G1 and G2 are in G, then we require that G1, G2 acting on X equals G1 acting on G2. How have I written it? I've just written it just by juxtaposition X. So this looks like associativity, but it's not. Associativity is this. That's associativity, where A, B and C are all on the same footing. Here, this fella is in X. Okay? So what have we got? To calculate this guy here, we go G1, compose it with the, I guess I should have put a little circle there because I originally specified my group to have a circle as its operation. So we take G1 and G2 and X, we combine these guys to give G1, G2, and then we put the X after the end of it to make to map back to our ground set X. How do we do this one? Well, we've got G1, G2 and X again, so what do? First of all, we combine these two together to get G2X, which is in the set X, and then we combine these two together to make G1, G2 of X. So they're very, very different in flavour, these two guys here. It looks almost trivial, but there's quite a lot going on here. You see, here we've got a group operation and a single group action. Here we've got a group action and another group action. Here there's two group actions. That's one, and that's the other one in there. And here we've got a group action for that and a group operation here. So they're very different things. Just a little bit more terminology. If Gx equals x for all G and G, this is trivial. Yeah. So basically, we're taking, if the group, this is just boring. It doesn't matter which element you choose. You just get the same thing. And if you've got that, then you say it's a trivial group action. Okay, I'm going to stop there.